So we're starting a new unit now, and it's the last investigation in Chapter 3. So Chapter 3, Section 14 is the first section in this investigation. There's only about 2 or 3, so like I said, this unit will take us about a week in class to get through. Look at a couple basic examples of what we're going to do on Monday, Tuesday, Wednesday in class. We got some equations on the board, so we're stepping away from inequalities. So notice we're back to having an equal sign. It's not less than or greater than or anything like that. Equal sign. And what we want to do is we want to be able to graph these equations. Okay, so we're going to look at making a t-chart. So some people call it a table of values because it has x and y coordinates in pairs there. We call it a t-chart because it makes the shape of a T. But we're just using this to organize our coordinate pairs. So as we begin, it doesn't matter what you use for your x values. There's just some that make maybe a little bit more sense to use than others. So oftentimes, and most of the time, what I'm going to use is -2 through +2. So I'm going to be able to see what this equation's doing when x is negative, when x is 0, and when x is a positive number. So those are 3 different types of numbers that our equations or graphs oftentimes look different based on whether they are negative, 0, or positive. Okay, so now I just need to plug in my numbers. So I'm going to plug in -2, and I'm going to get -2 cubed. So what that means is -2 times -2 times -2. Now you're going to use your calculator for this a lot of times. Many people will. If you're good with the mental math, it goes pretty quickly. Just remember, if you have an odd number of negatives, so a negative times a negative times another one, my answer is going to end up being a negative. So these two will give me a positive, but then I'm multiplying times another negative, and a positive times a negative, my final answer will be a negative number. Okay, just as a little refresher. So -2 times -2 gives me +4. +4 times -2 gives me a -8. So I write down -8 next to the -2, and I know that -2, -8 is my coordinate pair. Okay, repeat that process. -1 cubed, 0 cubed. This one's a nice, easy one to do. 0 times 0 times 0. 1 cubed, and 2 cubed. Okay, now I've got some points here that I can do some things with. Okay, so what we're going to be doing next week is we're going to spend a lot of time then graphing these. So we're going to have an XY coordinate plane. I'm just sketching a graph here. We're going to keep these pretty detailed. We'll be using graph paper. So go over to about where -2 is, down to 1, 2, 3, 4, 5, 6, 7, 8, down to -8, -1, -1, 0, 0, and then 2, 8, and I get my points here. Now, we're going to be graphing a few different graphs. There's 6 of them we're going to look at, and they all have different shapes. So as I connect my dots here, this one isn't going to make a line. It's going to make the shape called a cubic curve. And it's cubic curve because we have x cubed. So that's where the name comes from. And that's what my graph looks like. Okay? So this is really what I want you to take away from what we did on Friday in class. And then what we're going to be doing Monday, Tuesday, Wednesday in class is creating a table of values or a t-chart, plugging your x values in, getting some y coordinates out, and now you've got coordinate pairs that you can then plot those points and then make the shape of your graph. Okay? Now, you can do this with a calculator. You could graph y equals x cubed on a calculator. You could do a Google search for x cubed. You get all kinds of information. What we're focusing on in Algebra 1, just the foundations of these 6 graphs, we're focusing on being able to do it without a calculator. Okay? We just got to start there, and then in the future, when we're doing things with it, you'll be using a calculator many times, but not for this unit. Okay? So let's talk about real quick about two other graphs, and these aren't the only two, but just as an example. Want to remind you of the exponent rules here. So the 3 meant I multiply each x value by itself 3 times. So 2 means to multiply it by itself twice. It does not mean to multiply by 2, but multiply by itself. So this is -2 times -2. This is -1 times -1, etc. Okay, this was an example we did in class as well. But with your calculator is really picky about using the parentheses, so make sure you stop and ask yourself what you think the answer is supposed to be, to make sure your calculator told you the correct answer. And I shouldn't say told you the correct answer. Make sure that you plugged in the correct information into the calculator. So you ask the calculator to perform a calculation, and it can only do what it's programmed to do. So you just got to really make sure you understand what it wants you to type in. Okay, so then one last one, just as another example, the square root of x. So here's a point where we might want to be a little bit more careful with the x values that we pick. Because if I square root, for example, if I square root 2, I come out with the decimal 1.4. And it's actually 1.414, repeating a bunch of other stuff after that. But that's hard to graph, okay? So stop and ask yourself, okay, what is this asking me to do? Now the square root is when I take a number and then I find another number where I can multiply by itself to get there. Okay, so like for example, if I did 0, what number times itself gives me 0? A lot of people say like, well, 0 times anything. Yes, you're correct. But what number times itself? And we know that 0 times 0 is 0. So the square root of 0 is 0. Okay, not a great example because we're working with the same numbers. So let's look at another example. 1. Okay, now also not a very good example. But what number, so the square root of, I'm square rooting 1, what number times itself is 1? Well, we know 1 times 1 is 1. Okay, so here's where my example comes in, is if I square rooted 2, I get 1.414, etc. And that's a hard number to graph, or to plot, so I don't know if I want to use that number. 3 is like 1.7 something, so I don't know that I want to use 3. So then ask yourself, what's the square root of 4? So what number times itself gives me 4? Well, 2 times 2 is 4, so my y-coordinate would be 2. So that might be a time where you don't necessarily want to use -2, -1, 0, 1, and 2. Maybe you want to be a little bit more picky about the numbers if you're going to graph this. Okay, so go on to 5, 6, 7, 8, etc. And you realize, hey, 9, the square root of 9 comes out to a nice whole number that I can graph easily. So the square root of 9 is 3 because 3 times 3 equals 9. Okay, so just as a reminder of how that math works, I don't want that part to hold you up when it comes to graphing, but just as a refresher. Okay, so I think that concludes the review that we need to do. There's many more things that we could talk about with graphing. If I looked at, for example, this problem we did in class today, there's some people who are held up on the idea that, well, in letter E, for example, if I subtract 4 from both sides, well, now that's a little bit friendlier because I have y equals. So please understand that there's a lot of previous learning that we're going to bring back. And I mean, that's just how math works in algebra the rest of the year. It's a lot of stuff that you've seen, and we're going to put it all together, put a bunch of individual skills together into a new, maybe bigger or more complex scenario. So things like that, subtracting 4 from both sides, now all of a sudden I can plug in x and y values a little bit easier. That's going to come up. I can remind you of that sort of thing. But be prepared to think outside the box a little bit and think about, well, what skills do I have to be able to do this, okay? So if you can do what's on the screen right now and you have a pretty good understanding of that, you'll be in good shape for Monday's class. If you feel like this is not quite sinking in what happened there, you're going to want to go back to the video and rewatch that portion, or maybe rewatch the whole thing, so that you can come to class with a pretty good understanding and we can spend class time really working on what we're trying to learn here.